Okay, so this video I'm going to show you how to do a residual analysis. So what it basically is, or what a residual analysis is for, is to test or to further prove that the data that you've got is truly linear. So this is our data that we got before: ice cream sales versus temperature. And we want to really prove that this data definitely has a linear relationship between them. So we use what we call a residual analysis. And to calculate residual, it's the actual y value minus the predicted y value. So the actual y is the y value that you have. So these would be your actual y values. And your predicted value would be the y value you'd get if you use the equation to predict it, okay, using the temperature. So whatever the equation is, I'd substitute the temperature into it, and then whatever I get for y would be my predicted y value. And if you substitute the actual value minus the predicted y value, you would get the residual. But I'm not going to go too much into that. You have notes on that. I'm just going to show you how to do it on your CAS calculator. So in order to bring out all the residuals, you highlight a grey cell in your calculator on your spreadsheet. So this is the data I'm dealing with. And what you need to do on your calculator is you're going to press this variable button right here, okay? When you click on it, you could see that there's these options. You're going to click option 3, which is linked to, and you are going to do the residual analysis. Now, it's the one that ends with resid. Now, you can see that there's actually 2 here. That's because I put extra data on another page and it's getting confused. So if you keep your, if you minimize the number of pages that you have in a document, you would less likely be confused with which one to use. But I know for sure that I used my second one, or the number 2 one. Okay, but hopefully you'll only have one to choose from to do that. So I click onto that, and what this basically is this whole list is your residuals right there. Okay, can you see that? So that's one method of obtaining, or this is the only method of obtaining your residuals. The other method, you can actually graph your residual plot. So if you go to your scatter plot, all you need to do is press the menu button. We go to analyze, and we want the residuals and want them to show us the residual plot. So it's menu 472. As soon as you click on it, we have our residual plot right on the bottom there. Now, the significance of this residual, we're not doing plots for the fun of it, is because we want to actually see a trend. Now remember, zigzag means that the data is truly linear. If you see happy or sad faces, then the data is non-linear, okay? And in this case, as you can see here, the values, if I was to draw lines to attach each dot as I go across, this would go down here, then up, then down, then up, and down, and up, and down, and up. And this would be a zigzag, okay? As you can see, the data is scattered above and below, and if you join lines between them, it would just zigzag up and down. So this data is truly linear. This is what this is for, okay? To test for linearity. Another way you can look for it is, instead of doing it in a plot, you can just go back to your list of residuals, and just by looking at the list of residuals, the fact that there's negative and positive numbers scattered with no particular order, no particular trend, it means that this does follow a zigzag pattern, which means the data is truly linear. Okay, so it's linear because the residuals are positive and negative, or they kind of sit above and below that 0 line. Can you see the 0 line here? So it's random. That's the word I'm looking for. It's the plot is scattered randomly around it. Okay, so that's one example of a residual plot. Let's do another one just for practice. Okay, so over in this document, I have another set of data. And remember, when we're labeling our columns, we always put the X in front of the X variable and the Y in front of the Y variable, just to make it clear for ourselves. So this data is the growth of bacteria in minutes, okay? Okay, so I just made that up. X is going to be minutes, okay? And and y is going to be the number of bacteria. Okay, and let's do a residual analysis on that. So first thing you do when you're doing a residual using the spreadsheet method is to perform a linear regression. So menu 413, and x for x, y for y, whoop, where did I go? Y for y, and D is an empty column, so that's okay. And then what I can do is I could generate the residuals in one column. So once again, highlight a grey square in an empty column, go to your variable, this button here that's highlighted in red right now, I click onto it, you get three options, you link to, and you would link to your residuals. Now can you see how I've only got one thing that says resid? That's because this document is clean. It's only got this one set of data. So that minimizes your confusion as well. So just click on that and all your residuals will be brought up here. Okay, now how do you interpret this? Well, I'll show you the graph first. Let's just graph this. Oh, let's graph the plot and then graph the residuals. So once again, purple icon. X variable should be your X, Y variable should be your Y. Okay, and without even analyzing, you can kind of tell it doesn't actually follow a straight line. This line or this plot is curved. Okay, so we kind of already know the answer, but here is the proof. So to prove that, we're going to press menu, we're going to analyze, residuals, and I suck. What did I just do? I can't get my residual. I think I have to put the regression line in first. Let me try that. And so yes, once again, just like the spreadsheet method, you actually have to do your regression analysis to begin with. Here you do the same thing. So you put the line of best fit or your regression line, and then you can go menu 472 to bring the residual. Okay, so this is your residual here. You can see this is what we call a smiley face or a happy face. And if you get a happy face, remember the data is non-linear. So same if you get a sad face. So a sad face would be something that would curve this way, going up and then going down. That would also be non-linear. So this residual analysis, this plot, residual plot, is proof that this data is non-linear. Okay? Now how do you tell on your data? Now you could see, now in an exam you'd never say, oh, it's non-linear because it's a happy face, because your examiners won't be too happy about that. If it's a happy face, okay, the residuals start off being positive numbers and then become, oh, I'm horrible today, become negative, then back to positive. Okay, as you can see here. So positive, then to negative, then back to positive. You can see some kind of pattern. Okay, positive to negative to positive. Whereas the original example I showed you, the first one, this one here, can you see how the negative and positive is just scattered everywhere? There is no trend. Okay, that's linear, and this one is not, because there is a pattern, which we could see in this plot here. It's a happy face. So that is residual analysis for you. So it's just to see whether there is a trend in the residuals, and the data is linear only if these residuals are scattered above and below the zero. If it has a trend going from positive to positive, then it's non-linear. If it's going the other way, so a sad face would go from negative to positive, then back down to negative, that would also be non-linear. Okay, and that's it. That's it for residuals. Now, residuals are really important because you'll need them for the next topic, which is transformations.